Hello, I welcome you all to your own channel MSK Learnium. In this video, we will discuss about the heat engines. So heat engine is what? It's an engine in which the high source energy is converted into mechanical work. So first of all, we will take the heat from the reservoir, and then that heat is converted into work done, and then the heat will be rejected at a low temperature reservoir, which we call it as a sink. So for that, we have a two temperature level we have to take. One is the source and another one we have a sink, right? The source is having temperature is T1, which is higher, and the sink is having, this is your sink, right? So this sink has a temperature is T2, okay? And in between this we are mounting one machine that we call it as a heat engine, right? So the source will give the temperature, the heat Q1 at a high temperature T1, and then this heat will convert it into work done, that we call it as a WD, and then all the heat is not converted into work, right? So there are the some amount of heat should be rejected. So let's say that Q2 amount of heat is rejected at a temperature of T2, right? So this is what mechanism of a heat engine. So heat engine, we can see the efficiency of a heat engine, that we can say neta of heat engine is equal to output by input, right? So output is what? Output is nothing but the work done, and input is what? We are supplying the heat, that is Q1, to the engine. So this is the heat supplied, right? So again, if you see, then work done is what? That work done is nothing but the heat supplied minus heat rejection by heat supplied, right? So heat supplied is what? Heat supplied is Q1 and the heat rejection is Q2. So your equation will be, that is Q1 minus Q2 by Q1, right? So that you know that heat is a function of temperature, so it will be become, that is T1 minus T2 by T1. This is the efficiency of a heat engine, right? Similarly, we have a reversible heat engine that we call it as a, that is the two types, means either it will be the heat pump or refrigerator. First of all, we will see the heat pump, right? Or you can say the reversible heat engine. Reversible heat engine means what? That in simple heat engine, the heat is transferred from higher body temperature to lower body temperature, but in reversible heat engine, the heat will flow from the lower temperature to the higher temperature, and higher temperature here it is nothing but the surrounding, that we can say the atmosphere. So second type of, we can see that here you can write reversible heat engine, reversible heat engine, right? Reversible heat engine. So reversible heat engine, or we can say that is the heat pump, right? Means you have a pump which is used for heating purpose, right? So here also you have a two temperature, that we can say this is the source, okay, and here we have a sink, this is the sink, right? And in between this we have a reversible heat engine we are using, that we call it as a heat engine, that is heat pump, right? So this is the reversible heat engine, but the direction of heat that will be in opposite direction, means from the lower body to higher body. So this sink having temperature, let's say this is T2, and the sink source having temperature is T1. The condition is that the condition is T1 is greater than T2. The heat is flowing in the reverse direction, means from the lower body temperature to higher body temperature. So you know that whenever the heat is flow from the lower body to higher body, it's a violation of second law of thermodynamics, right? So it means that in this case the system will not do the work, means, but work is done on the system. So whenever the heat is flowing in the reverse direction, work should done on the system. But if you look at the heat engine, that is work is done by the system, right? The work is developed here, or work is produced, but in this we will supply the work to the system. So this WD you are giving, so this is what you have a Q2, and this will be the Q1, right? So the performance parameter of a reversible heat engine or heat pump is known as the coefficient of performance, right? So now you need to find out the, here you have to make a point that performance parameter of a reversible heat engine, is known as coefficient of performance, right? Coefficient of performance, that in short we denote it as COP, right? So the performance parameter of a reversible heat engine is known as the coefficient of performance. In short, we will call it as a COP, that is coefficient of performance. So now we will see the coefficient of performance of a heat engine, right? So you can say COP of heat pump, that is reversible heat engine, or we can say the heat pump, right? So the heat pump means the purpose of heat pump is what? To heat the system, right? Means whatever the desired area is there, that desired area you should have to heat, right? So here we can say COP of a heat pump is nothing but desired effect, right, by work done. Actually the COP is same like output by input, but output is what? Output that you have to heat the system, right? And the input is what? That you are giving the work to the system, then only the system will do the work. See, if you don't supply the work to the system, then heat cannot flow from the lower body to higher body. So here the work done is the input and your heating capacity is the output. So output is Q1 and this is your input, right? So you can say here desired effect means what? That desired effect you are heating, so Q2 by work done is Q heat supplied minus heat rejection, that is Q1 minus Q2. So COP of heat pump is nothing but that is T2 by T1 minus T2, right? So this is what we have a COP of a heat pump. One more reversible engine is there, that we call it as a refrigerator, right? So next we will see our next topic is refrigerator, right? This is also one type of reversible engine in which in refrigerator also the heat will flow from the lower body to higher body. The refrigerator purpose is what? To maintaining the temperature below that of surrounding. So the purpose of refrigerator is nothing but it is used to maintain the temperature below that of surrounding, okay? So this is the purpose of a refrigerator. So refrigerator means what? It is reverse direction. That means again you have this is source and here you have a sink, right? And here you have a reversible heat engine, that we call it as a refrigerator, right? And the heat is flowing in the reverse direction, that is from the lower body temperature to higher body. This is T2 and this is the T1. So T1 is greater than T2, right? Now that you are giving the heat Q2 to the system, means heat is flowing from lower body to higher body. Again, when the heat will flow from lower body to higher body, means work is done on the system. So we are doing the work on the system, right? Means this is work input and you are supplying heat is flow from the lower to higher. So this will be the Q1, okay? Your desired effect is what? Your desired effect is cooling the system. So this is the cool temperature, right? Now, so the COP, that is performance parameter of a refrigerator, is also known as the COP, that is coefficient of performance. So you can say COP of refrigerator is equal to what? It is refrigerating effect, right, by work done, or in short you can say that COP of refrigerator is equal to refrigerating effect is RE, right, by work done, that is work done is WD, okay? So refrigerating effect is what? You have to cool the system, means you have to cooling. So for cooling means what? Maintaining the temperature below that of surrounding, means whatever the atmosphere temperature, that system temperature should be less than the surrounding. So it means this temperature you have to take, that is Q2 by work done. Work done is nothing but Q1 minus Q2 only, right? So this is what you have this you can say T2 by T1 minus T2, okay? So this is what you have a COP of refrigerator, okay? So that heat engine in which the heat is flow from the higher body to lower body. In heat pump, the heat will flow from the lower to higher, work is done on the system and desired effect is heating. In refrigerator, heat will flow from the lower to higher, work is done on the system and desired effect is cooling. So this is all about the reversible engine. So in next class we will solve some numerical problem. Please do like, subscribe and comment and share this channel. Thank you.